Good evening. This is Jamie Huseman. My written Zoom report on Module 2, Math for Teachers 1, Module 2. We're going over, Chapter 2, Sets and Whole Numbers, the number theory, and Chapter 3, Numerations and Computations. So in our written exam, we're asked to create a 3-loop Venn diagram to show all 8 elements of U, and it says that let U be A, B, C, D, E, F, G, and H. And if I can get down here to mine. So basically what that's saying is making all those numbers that were designated to A, B, and C, and they can only be in those numbers, but if you'll notice, there's also some of those same numbers that are shared with B and C. So this is a 3-loop Venn diagram. And I've distributed those letters according to that. And then we're asked to do some union to show the different unions and coordinations. So if B union with C from this diagram, we get that everything, B union with C, so everything that is in B and C is D, F, G, and H. And then B, question B, is A intersection with B. So everything that they have in common, not all together, but in common, and that's just H and D. And then we have the question C is B intersection with C. Again, that's what they have in common, and that is D and H. Question D is the union of A and C, so everything that is in A and C. And that is B, C, and then D, G, and H. If you'll notice that E and A are outside, they're not included in A, B, or C, but they were included in the U diagram. So they needed to be in the diagram, but not in any of the A, B, or C circles. And then on E, what is the complement of A? So everything that is not in A. So everything that's not in A is A, E, and F. And then in question F, again, we're being asked the intersection, what they have in common with, what is in common with A and C, and that is G, H, and D. And then G is a little tricky. It is A union with whatever is in common with B and C. So what is in common with B and C is H and D, and then whatever is a union of A and what's in common with B and C would be B, C, D, G, and H. And then very similarly, question 2, the diagram asks us to, if I can get the screen to load, describe of this Venn diagram, of shapes and colors and sizes. What is this describing when it's saying L intersection H? So again, we'll go down here, and I have that L with the intersection of H is all large hexagonal shapes. So L is for large and H is for hexagonal. And then B is C union of H. So that is all circular shapes or hexagonal shapes. And then C is T intersection the complement of R, so it's the triangular shapes that are not red. And then D is C intersection S intersection R, and that means that they're looking for small, or it's describing small red circular shapes. The number 3 is asking us about how to calculate, let's see, let me go back to that, I'm sorry. How to calculate the Arabic translations of these numbers, and it's just to show a key. I found the key in the textbook, but to show, I also pulled some off the internet and used these. I think they're fun solving problems to solve, but you do have to know how to do it. So on A, sorry, my computer's slow. I came up with 30,054. And then on B, 1937, C, 41, and D, 41,837. And again, those diagrams are in our book. I can show these again, but you're just taking what you have. So on that first one, there was, I think that's the first one, the pointy finger. Okay, let's do the, it's hard to explain it when I don't have it right back in front of me, but there's those. Okay, and then I thought these were really fun to do. Hold on, this computer. Oh. Okay, so the lattice multiplication, we're multiplying, I'm sorry, my paper got a little bit wet there, 48 by 32. And if you have a hard time multiplying large numbers and you don't want to do it up and down, this lattice multiplication is very fun and easy. So you're going to have your first number on top, and your second number down the side, and you divide those in a square, and then you take a diagonal of each square. So if you'll start with 6, or I'm sorry, if you go back up, 4 times 3, I want to make sure it's 4 and not 2. I'm sorry, oh, it's 2. Okay, that helps. Sorry. 2 times 3 is 6. This top number is a 0. I know you can't see that because it's messed up. And then you'll take 8 times 3. And so 2 goes in the top of the diagonal, 4 goes in the bottom. So 8 times 3 is 24. The 2 goes on top, the 4 goes on the bottom. 2 times 2 is 4, so 0 goes on top, 4 goes on the bottom. 8 times 2 is 16. 1 goes on top, 6 goes on the bottom. So, and then you'll take the diagonal of each and come down. So 6, and then you'll take 4 plus 1 plus 4 is 9. And then the third diagonal is 2 plus 6 plus 0, that's 8, and then that top diagonal is 0. So the number we come up with is 896. And I repeated this process on B. The answer is 171,444. C, the answer I came up with was 571,652. And then on D, we came up with 1,203,336. And these are fun problems to do. Okay, and now we'll go to estimation. Rounding. We're going to round these numbers up. So when you round, you're rounding to the furthest number to the left. So if that's above 850, you round up. If it's below the 50 mark, you round down. So 883 rounds up to 900. 465 rounds up to 500. And if you divide that is, if you multiply that, or add that, 1,400 divided by 100, because we round down when it's 134, estimates to be 14. Now, the actual 883 plus 465, and then divided by 134 is 10.06. So estimation, you can always get close to your number, but it's obviously an estimation and you're not going to get it to the actual number. On B, we take 5 times 254 plus 523. Following order of operations, the estimation of this would be 50. And then when we solve the actual problem, it comes to 42.7. 5, again, we're rounding to that furthest left number, and when we go below 50, we go down. So it's 600 plus 400, and then we divide by 300 because we're rounding up, and that estimates out to 800, but the actual answer comes to 909.90. And then on number 6, we're doing our base 5 and 6 addition and subtraction. And basically all this says is that when we are adding, normally we just use our base of 10. And so nothing above 10, it has to be carried over if it's above 10. But on base 5, it's following the same order of operation, but when it's, well, you can only use the numbers 0, 1, 2, 3, and 4. And so when it goes above that, you have to borrow when you're subtracting. You have to carry when you add. So 2 plus 3 is 5, but we can't use 5, so we'll put a 0 in and we'll carry the 1. So that is 4 plus 3. We carry a 5, so that's 5. Is that right? I don't think I might have done that wrong. Oh no, 4 plus 3 is 7. Yes, 7. And then you can't have above 4, so you carry that 5, and that's 2 remaining. And then, so we carried that, and that's 5 plus 1, but we can't have 5, so we have to carry another 1, goes over there. And again, this is done the same process in B. And then on C, when we're subtracting, in B, we're using a base of 6, so we can use 0, 1, 2, 3, 4, and 5, but we can't use 6. So when we're when we go above 5, we have to carry 8 plus 3 is 11. So 6 minus I'm sorry, 11 minus 6 is 5. Carry the 1 for that 6, and follow the order of operation. So 7 plus 3 is 10, minus 6 is 4. We carried that 6 up here, 7, and then we would carry that other 6 and continued on. And then for the base 5 subtraction, you have to borrow. So 4 minus 3 is 1, but we can't take 1 minus 4 because it makes a negative number. So we want to borrow 1 from 4, and that makes that 6 minus 4 is 2. And then because we borrowed it, we took that down to a 3 and carried that 3 down. And then again on D, the same order of operations. So we borrow, because 3 is less than 4, we have to borrow, and this is a 0, so we had to go another side over. So we take that 5 down to a 4, we borrow to make 0, 5, but we also had to borrow from 5, so it's a 4. And we add 5 to 3 to make 8. 8 minus 4 is 4. 4 minus 2 is 2, and then 4 is dropped down there. So, and then we always, when we have our answer, we need to make sure that we're putting that base number on the bottom. That's been my written exam. Thanks for watching. Have a good day.